Now I introduce model-free reinforcement learning. Reinforcement learning uses one of the two following methods to learn a policy. First one is model-based. In model-based method, system dynamic and real-world function is known during the policy search. That means agent knows its environment. So it knows the next state when it takes action. In the second method is model-free method. The system dynamic is unknown. That means the agent doesn't know its environment. So even it takes action, it doesn't know what's the next state. So it needs to explore its environment and then to find the optimal policy. Now we explain the model-free reinforcement learning. It's many different methods based on the model-free model. But right now we use Q-learning to explain the model-free reinforcement learning because Q-learning is a typical model-free method. Its Q update follows this formulation. Here is this maximum. That means we select an action, make this Q value is a maximum. So we get the maximum variation from state ST to SPT plus 1. Then we update the Q function at state T for selected action AT. That means from this point, at the state S for selected action A, since we don't know the system dynamic, so we don't know even for this state S and selected action, we don't know what's the next state because we don't know the state transition probability. What we need to do, we need to use all the possible state as the next state. That means we try each state as the next state. And then based on this state, from this state, we try to find action. See how can we get the maximum Q function. Once we get the maximum Q function, then we have this difference, this increment. And then we can update the Q value at the state ST. That means from this pair S and A, we have to try all the states as the next state. And as this state, as use this state as the next state, we try all the possible actions. See which action can generate a largest Q function. That means an agent needs to explore in the state space and in the action space. He needs to access all the nexus, all the space, and all the action to find from state ST, take action A, and what's the next state. So he found the next state by solving this update equation. That's the idea. Because the main reason, because we don't have this state transition probability. So from S, we don't know where we go, where is the next state. So we need to explore all the state and all the action spaces. let's see a popular example, this cliff walking problem. Let's start this as standard for start point. This goal is our goal. So we need to start from this start point to this goal, this cliff. So if we know the system dynamic, that means we know how to cross this cliff without fall off this cliff and safely from S to G. However, since we don't know, that means the agent doesn't know this environment. So it need to explore this environment and then see how to find the optimal policy from this initial start point to the goal. For example, here they design a real-world function is if from a state in this world direction we got -1. We are from one state to another also get -1, except from this state we fall off into the cliff, we get a -500 or 100. Then we go start from a start point. From here, if we go to the wall or edge, we get a -1, but we keep the same state. So in this way, we have to, for example, step by step, some here, then we go this one. If we go here, we get a -1, we still in the original state. We go the upper direction, we got a -1. We try this direction, we get a -1. If from this state, we go this direction, we got a -100, we start from a start point. If we go this direction, we got a -1. Go this direction, we got a -1. And step by step, an agent explores the environment. And finally, through his exploration, he found the best way from a start point to the end point. Just follow, using the Q-learning method, just follow the idea because we don't know what's the next point. We have to try one by one, try all of them. And then for each of them, we have to find action from all the possible actions. Let me see in action space, we find all the possible actions and see which one can generate largest Q function. And then we update the Q value at SDS for selected SAT. For more information, please check with this reference. Thank you. Bye.